This PowerPoint looks at rocks and the three different rock groups of igneous, sedimentary and metamorphic. To look at Ireland's main rock types, first of all, you could say that they're sedimentary. As you can see the grey area here, you get this diagram quite a lot on the junior cert paper. You can see the grey area is limestone, but also sandstone and shales. They're also sedimentary rocks, so that would tell us that at some stage Ireland was submerged underneath a shallow sea, which we'll look at when we come to sedimentary rocks. But to start first of all on the igneous rocks. Igneous rocks are basically lava when cooling on the surface, or else magma as it's called when it's under the surface, cooling slowly. So in other words, extrusive rocks are on the surface, intrusive rocks are inside the surface. So extrusive are basalt, is basalt as an example, and it cools quickly because it comes in contact with the air or maybe the sea, it might be on the coastline. So because it cools quickly, crystals don't have time to form, so only small crystals form in it, mica, quartz and feldspar. Those crystals are also found in this intrusive igneous rock, which is granite. But because granite cools under the surface, it's able to, the crystals have time to form and become larger. So that's why when you look at granite, as you see the picture in your book, for example, it's got lots of flecks of different colours, whites and blacks and silvers and things like that. And that's the crystals that have formed. Examples of where these can be found are the Giant's Causeway for basalt and the columns that you see, whereas granite is the Wicklow Mountains. That's the Irish examples. If you look internationally, these are found all over the world. These are the basalt columns, similar to that's in the Giant's Causeway, whereas this is in the coastline of Iceland. Iceland we looked at for the mid-ocean ridge, where lava is flowing out and the island is growing by 5 centimetres a year. But on the coast there, the lava flows out and hits the sea. Or this area is actually tidal, so the sea comes up and hits against this. So this is when the tide is down at the moment, or low tide. So you can see the columns. Whereas this here is granite. It's a dome, well, it's a half a dome shape. This was cooled much more slowly, and this is in America, Yosemite National Park. For sedimentary rocks, it's really an accumulation of sediment building up in a shallow sea, on the seabed. As you can see in this diagram here, when you look at the igneous rocks, which we just discussed there, this is your intrusive. It might cool inside and you get granite, your extrusive or your basalt on the surface. But that can be worn down and transported by rivers out into the sea. And this sediment is brought out and lands eventually on the seabed, which you'll see here. This will begin to build up in a moment. Now, it can be sediment of rocks, but it can also be an accumulation of marine life, so fossils of dead sea creatures or plants. And that can all be deposited and it can be buried on the seabed where it's compacted. So this is where a sedimentary rock forms, just on the coastline there or further out to sea. For limestone, the example, it's formed at the bottom of a warm, shallow sea, and limestone is made of shells and fossils which are compressed. So that's not where the igneous rock, as you can see in the mountains here, are eroded and brought out to the sea. Instead, limestone is the shells and fossils, so the marine life just sinking to the ocean floor and being compressed. When limestone is formed, it's a permeable rock, and there's a few more details about that the influence of it being permeable in the next section when we look at limestone features. The other sedimentary rock is sandstone, okay, and that's an accumulation of sand on the seabed which is compressed. So that's your sedimentary rock, sediments being compressed on a seabed, which then become exposed when the land is uplifted up out of the sea, like in Ireland's example, or when the sea levels just go down, maybe because of an ice age, for example. The metamorphic rocks then are formed by, this is a third group, and they're formed by an igneous and or sedimentary rock, which are changed by pressure or heat or both. So where you find the pressure is at a destructive plate boundary, which again was mentioned in a previous PowerPoint. You have a huge amount of pressure building up, and that can morph the rock, change it into a different kind of a rock. Or else you can get the heat as it comes down towards the magma, and that intense heat can change the rock also. So marble is changed from limestone if limestone is exposed to heat or pressure, or both, and quartzite comes from sandstone. They're the two sedimentary rocks we mentioned on the previous slide, changing now into metamorphic rocks.